We are witnessing a massive shift. Tech giants are racing for ultimate control. Beyond the hype lies the real turning point. This is where the future is being written.
Okay, forget literally everything you know about typical tech announcements. OpenAI just did something highly unusual. They didn't announce their secretive new internal model, known as Astra, with some massive PR event or a flashy product launch. Nope. Instead, its existence just quietly leaked out through a highly complex theoretical mathematics announcement. It's a move that flew totally under the radar for most people, but for those of us paying attention, it signals a seismic shift in what artificial intelligence is actually being built to do.
Okay, let's dive into this because this seemingly quiet leak poses a massive central mystery for the future of technology. What actually happens when you stop asking AI for an answer and start giving it a problem? We're going to use Astra today as our entry point into a world where AI doesn't just chat with you, it works independently. We're talking about deploying systems on difficult research problems that even brilliant humans often can't solve. It's literally changing the very definition of what we consider machine intelligence.
Now, to really understand what's going on, we need absolute factual rigor. So let's separate the noise into three distinct buckets. First, the verified facts. Astra is an internal next-generation model, and we know it was revealed via theoretical computer science. Second, OpenAI's claims. They state it's produced new results across difficult math problems and possesses advanced mathematical reasoning. And finally, reasonable speculation from experts. This all points toward a major transition to autonomous agentic AI and future systems acting as actual research partners. We want to remain completely impartial in this explainer, making sure we separate what we know for a fact today from what we expect for the future.
But you might be wondering, why mathematics? Why is this specific field the ultimate test of AI reasoning? Well, think about a standard chatbot for a second. It can easily write a convincing-sounding historical essay. It can creatively hallucinate facts, and it might take a human expert hours to notice the subtle errors. But mathematical research? It is uniquely unforgiving. Math does not care about eloquent phrasing. A mathematical result has to survive rigorous step-by-step reasoning. It simply cannot be faked, which makes it the absolute perfect proving ground for true artificial intellect.
Now, what's really interesting here is that we are witnessing a real-time clash between two completely different paradigms of AI. On one hand, you have generating an answer, which is the chatbot experience we're all used to right now. It's a short interaction, it's pretty surface level, and as we know, it's highly prone to hallucination. But on the other hand, we have this new frontier, a verifiable result. This paradigm requires rigorous reasoning, it's proof-based, and most importantly, it can be mathematically checked and verified. It is the literal difference between sounding smart and actually being right.
And that brings us to a completely crucial concept, formal verification. In simple terms, this is the process of proving or disproving the correctness of intended algorithms or theorems using pure mathematical logic. It basically allows an AI to rigorously check its own work before it ever shows it to a human. So, an AI system that can contribute to difficult mathematical proofs using formal verification, that is infinitely more significant than just another chatbot beating a standard benchmark score, because it means the machine knows for an absolute fact that it is right.
If we zoom out to the macro level for a second, we can see the broader evolution of artificial intelligence really clearly. Years ago, we started with simple conversational chatbots. Last year, the focus shifted to reasoning models that could think through problems sequentially. Today, we're firmly in the era of tool-using agents capable of executing basic software tasks. Next year, we anticipate the rise of long-horizon agents. And looking to the future, we are looking at fully autonomous research systems. Astra is basically a glowing waypoint on this exact aggressive path forward.
So the old model was simple. Human asks, AI answers. But this new agentic workflow operates way more like a project manager. A human provides a broad goal, and the AI just takes over. It plans its own research, utilizes external tools, and runs independent experiments. And crucially, when things go wrong, because they will, it evaluates its own failures and revises its approach before ever presenting a final result to you. Now, I definitely want to note that today's AI is not yet fully autonomous or infallible, but this project manager structure, it's exactly how future knowledge work gets done.
The real engine driving this entire shift is the hidden power of time. 10 seconds versus an hour or even a day of reasoning fundamentally changes what a machine can accomplish. When you give an AI system extended time to work on a problem, you move entirely away from a simple 10-second prompt generation. The system actually gains the ability to self-correct, to use memory, to persist through failed attempts, and to refine its own logic. Time essentially unlocks a new, compounding tier of capability that we are only just beginning to understand.
However, this brings us to a really critical and completely neutral counterargument, the autonomy paradox. The unavoidable fact here is that the more time and autonomy an AI system is given to operate independently, the more opportunities it encounters for complex, compounding failures. Think about it. A minor hallucination in minute 1 can easily snowball into a massive, unseen error by hour 3. The very independence that makes these models so powerful is precisely what makes them incredibly difficult to manage.
So the crucial point is that because of this paradox, greater utility inherently demands entirely new safety frameworks. Extended operation exposes hidden failure modes that our current short-term evaluations simply miss. You literally can't just grade an autonomous agent like a multiple-choice test anymore. Because of this, autonomy demands highly advanced evaluation metrics. It requires robust, continuous safety monitoring. It is absolutely essential to develop long-horizon safeguards alongside the models themselves, making sure we balance these incredible new capabilities with sophisticated frameworks that keep the models on track over hours or days of independent work.
And this reality fundamentally shifts the focus of the entire global AI race. The old strategy was basically a competition to build the smartest, most conversational chatbot. But the new, multi-billion-dollar question is this: who can build AI that performs the most valuable work with the least human intervention? That is the new strategy. It's no longer just a race for fluent text generation. We are in an all-out sprint for true, verifiable, autonomous utility.
And look, the tech heavyweights, Google, Anthropic, OpenAI, NVIDIA, they're all rapidly realigning their strategies for this exact race. They aren't just competing on language benchmarks anymore. They're competing to build systems that can independently reason and solve complex problems in the real world. Every single one of these companies is attacking a different piece of the puzzle, pouring billions of dollars into shifting artificial intelligence from passive conversationalists into active, independent problem solvers. But keep in mind, this intelligence doesn't just exist in the ether. It demands a massive physical footprint. To run more capable reasoning models, you need exponentially more inference, which is simply the actual computing process of the AI generating thoughts and solutions. That intense processing requires vastly more specialized chips, which in turn dictates the construction of massive new data centers. And ultimately, this pulls unprecedented amounts of power from our electricity grids. Long-horizon AI is triggering an unavoidable, very real physical infrastructure arms race.
So, what is the ultimate payoff for all of this massive physical infrastructure and unprecedented investment? It's right here: accelerating scientific discovery. This is by far the most inspiring potential of systems like Astra. Just imagine the possibility of an AI acting not just as a glorified search engine, but as a true collaborative research partner, one that actually accelerates real-world breakthroughs in biology, engineering, and material science. It is a breathtaking prospect, really.
Let's move to and see how this builds out in the research lab of the near future. An AI system could independently scour decades of scientific literature to find hidden gaps, generate a completely novel hypothesis, and then run thousands of digital simulations overnight. It would actively discard all the failed approaches and hand a neatly prepared, mathematically verified result to a human scientist the next morning. We aren't fully there yet, but for sure, this is the very real blueprint for how tomorrow's research will be conducted.
What this really boils down to is a profound philosophical shift in how we interact with technology. We're moving from AI as a tool, something that requires constant human oversight, merely summarizes what we already know and essentially just produces information, to AI as a partner. A true partner understands complex goals and discovers net new knowledge. It produces actual discoveries. Moving from a tool to a partner changes the entire fundamental trajectory of human progress.
Which brings us to this absolutely amazing idea that beautifully summarizes why the Astra anomaly matters so much. The biggest breakthrough in AI may not be the machine that answers your question better. It may be the machine you give a problem to on Monday and come back to on Friday to discover that it found something nobody knew before. That is what the ultimate race is actually about. Which machine can discover something truly new? And that leaves us with a final, pretty provocative question for all of you. Could systems like Astra become the ultimate research partners, helping us make discoveries in days that would otherwise take decades? Or, given the autonomy paradox we talked about, are we moving too quickly toward autonomous AI? There are no right or wrong answers here, but it's an absolutely critical conversation we all need to have. So, share your perspectives on the speed and direction of autonomous AI in the comments. Thanks so much for joining us for this explainer, and we will see you in the next one.